Hello everyone, welcome to Fab Lab Baltimore. We are a non-profit digital fabrication lab, community workspace, and educational center located at CCBC Catonsville. We offer classes in multiple forms of digital fabrication technologies and software to help students, artists, designers, entrepreneurs, and engineers evolve their making practices to meet and compete with the current industry standards. We also partner with outside organizations to host workshops, tours, and demonstrations that spread the word of the Fab Lab and digital fabrication. Beyond our classes, we are a functioning makerspace. We offer access to all machines in our lab during our community use hours. Now let us look at all the machines we have at the Fab Lab Baltimore and get inspired by some of the many projects that have come out of our space. 3D printing is one of the most well-known forms of digital fabrication. The manufacturing industry is now rely heavily on 3D printing for prototyping, which is the process of testing a product before high-volume manufacturing. There are many types of 3D printers out there and many materials you can 3D print with. The most common materials to 3D print are thermoplastics. It's like a plastic that softens when heated. And thermoset polymers is liquid plastic that is hardened by exposing it to the UV light. Here in the lab, we can print in a variety of these plastics with our FDM printers, which stands for fused deposition modeling, SLA printers, stereolithography, and our SLS printers, selective laser centering. We have a fleet of Formlabs printers in the lab. Formlabs makes user-friendly and reliable printers that churn out beautiful 3D prints. We have 2 SLA printers and 1 SLS printer from Formlabs. The Fuse One is both the newest addition to our lab and is Formlabs' newest printer. The Fuse One is SLS printer, which stands for selective laser centering. This means that it used a laser to selectively fuse together particles of a powder material into complex 3D-dimensional shapes. Currently, our Fuse One can only print in nylon powder, which is a strong and flexible plastic. The wonderful thing about the Fuse is that because it prints your parts in a bed of powder, there is no need for support structures, and you can stack as many prints into the building chamber as you can fit. With other types of 3D printers, this would not be possible as a support system would have to be edited. Once your parts are finished printing, they are excavated from the powder cake in the Fuse's counterpart, the sift. The sift is a specialized hood to clean off parts and protect the user from breathing in the microplastic powder. Because the Fuse prints are solid parts, our prints are extremely strong and can withstand a great deal of force put upon them. Here we have printed replacement gears for our colleague John over in the machining department. John modeled these gears in a CAD software called SolidWorks. They are modeled to fit together and are used to create a governor, also known as speed regulator, for a steam engine. Another Formlabs printer in our lab is the Form 3BL. The Form 3 and its counterpart, the smaller Form 2, are both SLA printers, which stands for stereolithography. These printers use a UV light to cure photopolymer resins into a complete 3D print with edited support structures that are clipped away in the post-processing. The Form 3BL was edited to the lab to allow us to print large-size prints as well as print in a biocompatible material. One of the projects that we completed using the Form 3 was a stage prop project for CCBC Theater Department. They needed 40 of these 3D printed soldiers for their performance of And Then There Were None. The soldiers needed to be printed hollow so that they could break easily on stage. We lost a couple of prints during the process of printing 40, which taught us to always prepare for mishaps during a project. After all 40 were printed, the CCBC Theater Department hand-painted each soldier. As with the Form 3BL, the Form 2 is another small SLA printer. Both printers can print in a variety of resin types that have a variety of properties. Some resins are stronger than others, some withstand heat better than others, some are more flexible than others, and so forth. Because of this variety, the Form 2 and 3 are great for prototyping in a variety of products. An engineer from Lumen Ultra, a biotech company, utilized our Form 2 to prototype a bead dropping machine. This machine drops chemical mixtures into liquid nitrogen to form frozen beads, which are then dried so that otherwise unstable reagents can be easily stored and transported. Lumen Ultra uses this process, otherwise known as lyophilization, to create microbial testing kits that can be used to test for diseases like Legionella or COVID-19. The Form 2 printed the prototype of the part that was submerged in a liquid nitrogen to prevent the excited beads from touching and merging. The most common form of 3D printer is the FDM printer, which stands for Fused Deposition Modeling. FDM printers print by heating up a spool thermoplastic to extrude the melted plastic onto a build platform in layers until it builds the entire model. In our lab, we use the MakerBot Method X printer as our primary prototyping printer because it can create 3D prints at low cost and in a variety of plastics. The reason the cost is lower than the SLS or SLA printers is because with FDM printing, you don't have to print your part solid. Instead, you can print with different amounts of infill that will use less material than printing your parts solid. As with all of our 3D prints, however, you are not just limited to testing your design by printing prototypes. You can print finished pieces that can be utilized depending on the materials you print them with and the density in which you print them. We have printed lots of gear and handle replacements using our FDM printers for the machine shop next door. For this, we either print them in a solid ABS plastic or a high-density nylon carbon fiber. Moving on to some of the bigger machines in the lab, this is our ShopBot CNC router. A CNC router is a great tool to use on a larger projects such as a furniture building, 3D milling, or large-scale sign work. The CNC router uses a spinning router bit to cut your material using XYZ coordinates that are created using a tool pathing software. This means that you can cut accurately and consistently. The ShopBot accepts material as large as 4 feet by 8 feet in width and length, and about 3 inches max in height. Common materials cut on a CNC router are sheet plywood, foam, hard and soft plastics, and thin aluminum. We have created some custom furniture for the lab using our ShopBot. We needed a computer cart that would fit in a particular area of the lab that had some storage. Before cutting, we designed the cart on a CAD modeling software called Rhino 3D to make sure that all the doors and hardware would fit. Then we extracted the cut lines from our design and ran them through the tool pathing software. After cutting those parts on the CNC, assembly was extremely easy because all the parts were modeled to fit together with minimal need for screws. Another amazing project on the CNC router was created by one of our teachers. Kyle, an adjunct professor here at the college, used the CNC router to prototype a belly pod for a carbon cup FX-free plane. His prototype went so well that now he can move on to CNC the forms for the composite mold making process he will use to create the actual belly pod. Moving on to the most popular tool in the lab, our laser cutters are a fast and easy way to cut and etch into a variety of materials. We have 2 CO2 laser cutters in the lab, which means that the laser beam that is used to cut through your material is made in the chamber of CO2 in the back of the laser. Laser cutters are fantastic machines that make cutting through thin material fast and efficient. Be warned, however, that laser cutters cannot cut all materials. Some plastics, foams, and rubbers are toxic when cut with the laser, so make sure you research your material before trying to cut in a laser cutter. Laser cutters are also limited by the thickness of your material. Generally, our laser cutters can handle cutting through material up to 3/8 inch thick. Because of how fast laser cutter works and how clean of a cut it makes, it is the most popular tool in our lab. Our lasers have been used to create many projects, Recently, one of our members, Sarah Dietrich, a local Baltimore artist, used our lasers to create the work that were showcased in her Soul exhibition. Sarah cut into cyanotypes to create sculptural paintings that mixed images from nature and the human body. Because of the speed of the lasers, Sarah could cut through many cyanotype prints into one laser session. Lasers are also amazing for sign making. As a resource for the college as well as a community space, we have been working on making signage for new buildings at CCVC. All of the signs were made using the laser to cut through a variety of plastics that were layered onto one another to create these ADA accessible signs. Using multiple machines and processes to create a finished project is a common practice in digital fabrication. On this project, we used the CNC router, the laser cutter, and some electronics to complete awards for a college-affiliated group that needed awards that lit up and spoke. We used the CNC router to cut out all of the internal channels to run the electronics through, so that when you press the laser cut button on an award, a voice would give you an audible congratulations speech. I hope that you enjoyed this tour of our lab and were inspired by some of the projects that have been made here. Our hope for the space is to bring as many people into digital fabrication fold, so if you are interested in learning more about us and potentially taking a class, please check out our website at www.fablabbaltimore.org. Thank you very much for watching.